Okay, so now I'm going to show you guys how to do the tangent line problem. So this is when you're given a function f and some point p on the graph and asked to find the equation of the tangent line to the graph at point p. In almost all cases, this is the same as finding the slope of the tangent line, except for cases involving a vertical tangent line, of course, because then it is undefined. So kind of just to give you an idea, so if you have this function here, and it'll ask you to find the tangent line, and let's say this point is point 1, 2, and an example problem would be to find the line tangent at this point of this function. So that's just a general summary of kind of what the tangent line problem is. Now you can approximate this slope by using secant lines on the graph, and this approach would involve you using the definition of a limit and its formula. So the definition of a limit is and this would give you the slope of these secant lines. And what you would get is you would start here and slowly approach closer and closer to this line, and it sort of creates kind of a limit that you're approaching, and that limit is the slope of the line. However, this is a longer approach, so I'm going to show you a different method. So, for example, let's see here, okay. Given the equation, let's say 5x minus 2 over x squared plus 1, let's say the problem asks you to find the equation of the tangent line with this function at point 1, 3/2. So you are to find the slope of the tangent line at this point in the function. In order to find this, you first find the derivative of the function, of the given function. In this case, you will probably need to use the quotient rule. I think it'd be the easiest way to find the derivative of this. So I'm going to go through the quotient rule with you first to get the derivative of this function. So just as a reminder, the quotient rule says for a given function f of x of g of x, like here, the derivative would be the following. It would be g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. So now using this, I'm going to plug in the appropriate function. So my g of x is x squared plus 1 times the derivative of f of x, which is 5, minus f of x, so that's 5x minus 2, times the derivative of g of x, which is 2x, all over g of x squared, so x squared plus 1 squared. Okay, so now that you've set up your equation, this is just, I set up the quotient rule here to find the derivative of the function. When this is being simplified, you just use your normal simplification rules, and you will get negative 5x plus 4 plus 5 all over x squared plus 1 squared. So this is the derivative of the function. You then plug in your x value of the point into your derivative. So we had our point was, let's go back, it was 1 3/2, so the x value is 1. So since x equals 1, we're going to plug that in here, so you have negative 5 times 1 plus, 4 times 1 plus 5 all over 1 squared plus 1 squared. When you solve this, you will get 1. And now this is your slope. So keep in mind, to go through this one more time, what we did is we took the original function, we found the derivative, plugged in the x value that was given in the equation, given in the problem, into our derivative, and the outcome is the slope of the tangent line. So now we have the slope, so m equals 1 is the slope. So now what we're going to do is, we're still not finished, we still have to find the equation of the tangent line. So the slope is 1, and in order to find the equation of the tangent line, you need to plug in the slope and the point that was given into point slope form. And just a reminder, point slope form is y minus y1 equals m times x minus x1. And remember, our original point I'm going to put up here was 1 3/2. Okay? So, and we know our slope m is 1, so we have y minus 3/2. I'm just plugging in the point that was given equals 1 times x minus 1. Plug that in. And now when this is simplified, you should get y equals x plus 1/2. And this is the equation of your tangent line, and that is how you solve the tangent line problem.